This question is about atomic structure. So this question is saying there is a general trend for an increase in ionisation energy across period 3. So the first thing I would do is I'd go and locate period 3 on your periodic table. So if we do that, we can see a periodic table here. Period 3 is this third row down, remembering that hydrogen and helium are the first row. So we're going from sodium to argon. And what we need to do is remember what the pattern is for first ionisation energy. So if you remember across a period, we get a little up of 2 and then a dip, and then we get an up of 3 and then a dip, and then we get another 3 up. So it goes sodium, magnesium, aluminium, silicon, phosphorus, sulphur, chlorine, argon. There's a general up, but there are some deviations from the trend. So if we notice, our first deviation here is at aluminium. And what is happening at aluminium is that we've gone, sodium has got 3s1 as its outer electron configuration, and magnesium's got 3s2. But aluminium, we've flipped across the periodic table into, from magnesium to aluminium into the p subshell. And so what is happening there is we're getting an outer electron in a p subshell, and the p subshell is higher in energy than the s subshell, and so there's a slight decrease. And then our next dip comes here at sulphur. And if we think about what's happening there, if aluminium is P1, silicon is P2, phosphorus is P3, sulphur is P4. So at sulphur, we've had to pair electrons in one of the p orbitals of the 3p subshell. And as a result, they're repelling each other. That slight repulsion is what gives that little dip in energy. So we have a look. We can see where those marks would be awarded. If we see here, we've got, if we've chosen aluminium, outer electron is in a 3p subshell that's higher in energy than the 3s. If we've chosen sulphur, the electrons in the 3p orbital have had to pair up. That causes a repulsion. So our next little part of the question says, give an equation including state symbols for the third ionisation energy of sodium. So first thing is I go find sodium on my periodic table, realise that it's Na, and then I would say third ionisation energy is removing the third electron, so I'm already 2+, and I'm going to become 3+ by removing 1 mole of electrons from 1 mole of 2+ ions. And the definition says in the gaseous state. And so we've answered that question. So our next little question asks us again about period 3. So we're reminding ourselves that period 3 is from Na on our periodic table to AR. So we just have another look back at our periodic table, familiarise ourselves with the elements: sodium, magnesium, aluminium, silicon, phosphorus, sulphur, chlorine and argon. And what we notice is that the ionisation energy sort of continues along, increasing slightly, but then there is a big jump to remove the 6th electron. What that tells us is that the 6th electron must be closer to the nucleus than the 5th, and therefore it's got less shielding, and that is why so much more energy is needed. And that means that there must have been 5 electrons on the outer shell. Now, if you have 5 outer shell electrons, you are in group 5. So we go back to period 3 and we find group 5, and we find the element, in this case phosphorus, that's in group 5. We go back and we have a look at our graph. So we're going to be answering that our choice is phosphorus, and that we saw a large jump to remove the 6th electron. The 6th electron is in an energy level close to the nucleus with less shielding. The bit in brackets not needed for your answer, but it does explain why it's in group 5. 5 electrons on the outer shell before that big jump, group 5.